Alright, in this video we are going to work some more complex conversion problems. They are not any more difficult. The steps are not any different. It's just there are more steps, and so just the number of conversion factors that you have to use when you step back and look at it, it makes it seem more complex. But if you will approach it one unit at a time, if you will use common conversion factors that you use over and over again, if you use conversion factors that are given to you, and if you can look at the problem and accurately determine what is the measurement that I'm given here, then you can approach any problem, no matter if it is just 1 or 2 conversion factors or 10 conversion factors. They all eventually will seem about the same to you. So if we take a look at this first problem, you'll see that I have a homeowner and they have a small propane tank, and the propane tank contains 4.81 gallons of liquid propane. If the density of the liquid is 0.493 grams per milliliter, how many pounds of the liquid are in the tank? So if you look, you've got two numbers, and again with two numbers oftentimes people look at that and they're not sure what to do. But we always want to start with a measurement and not a conversion factor. So one of the key things to look for to determine is it a measurement or is it a conversion factor, if you see the word per or you see anything that means per, then that will be a relationship between two units. One of the things that means per is a diagonal line, because that is a fraction bar. It's just written all on one line. But with chemistry, what we like to do is we like to write them as a different kind of fraction on two different lines. And so if you see something like this given to you in a problem, what you want to do is you want to rewrite it so that it looks like a conversion factor to you. So with conversion factors, we write down our numbers and units. So there's 0.493 grams per milliliter, and so the milliliter, the number that goes with that would be a 1. So now I've rewritten it. It looks like a conversion factor now. How big is this propane tank? Well, this is the volume of that propane tank. This is the measurement that we're trying to figure out. How much does that weigh? And so this is the measurement that we're going to start with. And so the first thing you want to do is you want to write down the measurement. So don't try to keep it in your head. Just write it down so that you can get it on paper and know where to start. Because once you have your measurement, you start by focusing on this unit. You want to take this unit and copy it on the bottom of the first equality because you want to get rid of it. So you want to think, what equality do I use? Again, with gallons, you want to think, do I go to quarts? Because normally that's what you do. And so in this problem, we want to get into the metric system. So yes, we do want to go from gallons to quarts because we want to go from a big unit to a smaller one. And then we can move from quarts into the metric system. And so we have here 4.81 gallons. We have gallons on top and gallons on the bottom. And so we should be able to cancel this unit now on top and on bottom. Now we have quarts. This is not the unit that we want, so we want it to be on the bottom of the next step. And when we have quarts, usually if we need to go into the metric system, this is where we would go to the metric system, and we go from quarts to liters. That's a very common conversion factor. So the conversion between quarts and liters, there's 1 liter, and that's the same thing as 1.0567 quarts. And so that will cancel the quarts. So now we have liters, and we want to get rid of liters. And at some point we want to use this density here as a conversion factor. So we want to go to milliliters. So this is just a metric conversion, milliliters to liters. There are 1,000 milliliters in 1 liter. Now we have the unit of milliliters, and we can use our density And so we want milliliters to cancel, so milliliters goes on the bottom. And the number that goes with milliliters in the density is 1. And 1 milliliter is the same thing as 0.493 grams of that liquid propane. So now we have grams that we want to get rid of. We want to go to pounds, so we're in mass now, but now we want to go into pounds. And so grams, we need to go to something. And usually what I do is I have students learn kilograms to pounds, and then whenever you need to convert between systems, then you just get to kilograms so that you can get to pounds. And so then we just have to use what we know about kilograms versus grams. So there are 1,000 grams in 1 kilogram. Now I need to get rid of kilograms because it needs to be on the bottom, and we would put pounds on the top. And so there's 2.205 pounds in 1 kilogram. So if we go through and we cancel, then we can cancel gallons because we have it on top and bottom. And we have quarts on top and bottom, so we can cancel it. So top and bottom. And we have liters on top and bottom, so it will cancel. We have milliliters on top and bottom, so it will cancel. And we have grams on top and bottom, so it cancels out. And kilograms on top and bottom, so it cancels. And unit-wise, we only have pounds left. So now we need to see what mathematical number this equals. And so we just do the math, the arithmetic, 4.81, and then I'm going to multiply across the top, so times 4 times 1,000 times 0.493 times 2.205, and then I'm going to divide by the bottom, divided by 1.0567, divided by 1,000, and I get this long number, 19.79287, and then it just keeps going. Let's make sure I wrote that down right. 19.79287 pounds. This is way too many digits, and so in measurements in science, we have to be only as precise as our given measurement is. And so more numbers is not a good thing. That's not better or more exact, because measurements are never exact. You can only be as precise as your starting measurement. The starting measurement you should have written first, which is the 4.81. So you go back to the starting measurement and you see that this starting measurement has 1, 2, 3 significant figures. So there are 3 significant figures. And you will round your final answer to the same number of significant figures. 1, 2, 3. So the 10th place will be what you round it to. And so you'll round, there's a 7, and then the next one's a 9. And so rules, if there's a 9 that comes after it, you would round up. So you would round your answer to be 19.8 pounds. 19.8 pounds would be your answer. You want to stop and think, does that not make any sense? 4.81 gallons. This is a small propane tank, and so this is something that you would get at the convenience store. And you can pick it up, which means it must not be extremely heavy, but it is kind of heavy, and you also would be picking up the metal component of it. But this is just a small propane tank, so it being about 20 pounds is about right. And often it's called a 20-pound tank. That is about the mass of the propane that's inside of that propane tank. Okay, the next problem that we're going to look at is about running a 10K. So it's often called a 10K, but that means it's a 10 kilometer. And so I just put that it was 10.0 kilometers. It may have even more significant digits than that because they try to be as precise as possible with these races. And so if you look through this, a runner averages a speed of 6.0 mph. How many minutes will it take them to complete a 10K, or just 10.0 kilometers? So we have two numbers that are given here. We have this rate of their speed, and we have how long the race is. So only one of these is the actual measurement. So again, whenever you look at something, if you see something that means per or is the word per, that is a clue that it is not a measurement but a conversion factor. So the 6.0 mph is not a measurement. It is a conversion factor between distance and time. And so I want to rewrite this 6.0. I want to write it to make it look like a conversion factor. And so it would be 6.0 miles per 1 hour. Okay, so I've rewritten it. The 10.0 kilometers is the race that this person's running, and you're trying to figure out how long does it take them to run this race. So that is the measurement that the problem is asking about. And so 10.0 kilometers is the distance. And so first thing, your first conversion factor needs to get rid of kilometers. And we need to go into our system, and the measurement that I use to go between systems is always centimeters and inches because it's an exact equality, and everything else is a bunch of rounded numbers. I choose just to use what I know about the metric system and what I know about our system, so that I only had to use the 2.54 centimeters. I don't have to learn to 5 digits how many kilometers are in a mile or how many miles are in a kilometer. And I don't have to figure out how many feet are in a meter because I know how many meters are in a kilometer. So I'm going to choose what I know about the metric system, which is 1 kilometer is the same thing as 1,000 meters. And then I'm going to cancel meters and convert it to centimeters. So I always go to centimeters and then switch over each time, no matter how many steps it is to get there. So I kind of just get used to going to centimeters. If I want to get rid of centimeters and convert it into inches, then I will use the common exact equality of 2.54 centimeters is the same thing as 1 inch. Then you have inches, and you want to go larger, and so inches into feet. And this is a common equality that most people know. So you don't have to learn anything new. Use what you know. So I'm not sure if you know how many miles there are or how many feet are in a mile, but that is a common one that makes the other ones much more convenient to learn. There are 5,280 feet in a mile, and that's a definition. That's how many feet are in 1 mile. So from here, we can actually use the speed that the person travels. And so we can do the 6 miles because I want to get rid of miles. So it's 6.0 miles per 1 hour. And I want to know how many minutes. So you just have to use, there's 60 minutes in an hour, and that is an exact equality, both of those, the six minutes in 1 hour and the 5,280 feet in 1 mile. Those are exact equalities. So if we go through here, we can see that kilometers cancels, meters cancels, centimeters cancels. These units are going to cancel out because we put the unit on the bottom. So feet will cancel, miles will cancel, hours will cancel, and we're left with minutes. So we go through and we do the arithmetic that we have outlined here. So we start with a 10, and we multiply it by 1,000, and then we multiply it by 100, and then we multiply it by 60, and then we go back and divide by anything on the bottom. So we divide by 2.54, and we divide by 12, and we divide by 5,280, and we divide by 6. And I get 62.137, and then it just keeps going. So 62.137, and then dot, dot, dot. And this is how many minutes. So we want to just round it. I gave the starting measurement in terms of 3 significant figures. And so I need to round my answer to 3 digits. So that would be the 10th place, because 6 and 2 and then the 1 in the 10th place is the 3rd significant figure. So if you round it, then you get 62.1 minutes as your answer. And then you ask yourself, does it make sense? And so this is a 10K race, and 62.1 minutes is a little more than an hour. Does it make sense that it would take somebody about an hour to run a 10K? And yes, that does make sense, because 6 miles an hour is pretty good pace. It's about a 10-minute mile. Okay, our next and last problem on this activity is just an example of a person and something they do every day. So we have a person, and they drink a 24 fluid ounce Mountain Dew each day. How many pounds of sugar will they consume in August? And so you're also given that there's 8 fluid ounces, and they contain 31 grams of sugar. And so what we're looking at, if you see this 24 fluid ounces of Mountain Dew each day, this actually is a conversion factor, because it's the relationship between a container of Mountain Dew and a day. And so this is not a measurement. This is a conversion factor. And so the first thing that you see is the 24 fluid ounces per 1 day. So that's actually a conversion factor. We want to know how many pounds are in that they'll consume in August. So August, the whole month of August, is really what the question is about. And so we want to think, okay, if they are consuming Mountain Dews every day, how many days are in August? And so we could just put August as our start here, or we could put how many days are in August. And so I'm just going to put 31 days, because that's how many days are in August. But again, you could start with August, and then if you have 1 August, you would have 31 days. And so then August would cancel. Okay, so I want to get rid of days. And as soon as this unit matches something that you're given with the same unit, you want to use your given measurement. And so in 1 day, this person consumes 24 fluid ounces of Mountain Dew. And so that converts from time into Mountain Dew. But in fluid ounces is not what we want. And so we want to get rid of fluid ounces of Mountain Dew. So fluid ounces of Mountain Dew is what we're going to put next. And we are given a conversion factor here. Here's another one. 8 fluid ounces contains 31 grams of sugar. And so this is a relationship between the drink and what's in the one of the things that's in the drink. And so 31 grams of sugar per 8 fluid ounces. This would be the next conversion factor that we are going to be using because we want to get rid of fluid ounces of Mountain Dew. So if we have 8 fluid ounces, this person is going to consume 31 grams of sugar. And so now we're actually in mass of sugar. So we want to go to pounds, and we've done a problem like this in a previous video. I usually go to kilograms and then from kilograms to pounds. And so I want to get rid of grams and go to kilograms. If you use the same kinds of conversion factors over and over, it makes them much easier to recall. There's 1,000 grams in a kilogram. That's just a metric conversion factor. I want to get rid of kilograms and go to pounds. Again, if you use it quite a bit, it makes it easier to recall what it is. So there's 2.205 pounds in 1 kilogram. And everything is going to cancel except for pounds because I went one conversion factor at a time. Pounds is left. So use calculator and just do the arithmetic. We got 31 times 24 times 31 times 2.205, and then we divide by 8 and we divide by 1,000. And so it is 6.35715. Okay, this is more significant figures than we need. Now this one's a little bit different because the beginning amount is a number of days. It's not really a measurement. And so we have to kind of look at the numbers that we're using in between. And so I'm just going to say 2 significant figures because of the container of Mountain Dew and then the 31 grams. Both of those are not real precise, so those are 2 significant figures. And so I'm just going to round to 2 significant figures. Usually it's going to be more obvious than that. But 31 days is not a time measurement, it's counting of a day. And so 6.4 is what you would round to, and then your unit is pounds. So the 10th place is your second digit, and so you're going to round up because the 5 comes next.